For over a century, astronomers have been staring at a bright speck of light between Mars and Jupiter. In the vast, dusty expanse of the main asteroid belt, millions of rocks are spinning in the dark, most of them completely ignored. But this one was different. They knew it was big, and they knew it was weirdly bright, but they had absolutely no idea it was staring back with 3 heads. In early 2026, scientists pointed some of the most powerful ground-based telescopes ever built at Asteroid 44 Nysa.
What they found wasn't just another space rock. It's the first trilobate, or three-lobed asteroid ever discovered in our solar system. And to make things even crazier, it has a tiny moon orbiting it. So how does a massive 75-kilometer-wide mountain of rock get shaped like a cosmic fidget spinner? And what does this weird 3-headed mutant tell us about the violent, chaotic days when our own planet was born? Buckle up, because the story of Nysa involves ancient cosmic pileups, groundbreaking telescope tech, and a 4.5 billion-year-old game of billiards.
To understand why Nysa is such a monumental deal, we have to rewind to its discovery back in 1857. For decades, it was just a dot on a photographic plate, but it was a suspiciously bright dot. Nysa is what we call an E-type asteroid. The E stands for enstatite, an extremely rare silicate mineral. Basically, instead of being a dark, carbon-rich lump like most asteroids, Nysa is highly reflective, acting kind of like a dirty mirror floating in deep space. Most asteroids in the main belt absorb almost all the sunlight that hits them, looking like floating lumps of charcoal.
But Nysa shines. In fact, scientists think E-type asteroids are actually made of the exact same pristine raw materials that built Earth and the other rocky planets. So looking at Nysa isn't just astronomy. It's essentially looking at the leftover scraps from Earth's original construction site. We even have tiny pieces of E-type asteroids that have crashed into Earth as rare meteorites called aubrites. But tracking them back to a specific parent body in space has always been a guessing game. But the extreme brightness wasn't even the weirdest part of the Nysa puzzle. As astronomers monitored the asteroid over the years, they noticed its light curve was behaving erratically. As Nysa rotated, its light would dip and spike drastically every 6.4 hours. Imagine shining a flashlight on a spinning dinner plate, edge on versus flat. The amount of light reflecting back to you completely changes. Astronomers knew right then that Nysa wasn't a perfect sphere. They ran the math and thought, okay, maybe it's shaped like an elongated potato, or maybe a cigar. It was a solid guess based on the tech of the 20th century. Boy, were they wrong.
Enter the year 2026. A research team led by astronomer Kate Minker from Lowell Observatory decides to finally solve the mystery of Nysa. So they pull out the big guns. And by big guns, I mean the Large Binocular Telescope in Arizona and the Very Large Telescope down in Chile. To get a clear picture of something that small and that far away, they used advanced adaptive optics.
This is straight out of sci-fi. They shoot massive lasers into the sky to measure atmospheric turbulence, and then a computer physically bends the telescope's mirror hundreds of times a second to cancel out the blur of Earth's atmosphere. When the razor-sharp images finally came through, nobody expected what they saw. Nysa wasn't a potato. It was 3 distinct rounded lobes, heavily cratered and connected by 2 narrow necks. It's a highly complex structure scientists call a contact trinary. It literally looks like a 3-headed rock, or a really deformed, battered snowman tumbling through the void.
And just as the team was processing this bizarre, unprecedented shape, they noticed a tiny, faint speck hiding in the glare of the background. Nysa isn't traveling alone. It has a moon. This tiny, 1-kilometer-wide satellite is orbiting about 170 kilometers away from the main body. It's like finding out the weird 3-headed dog you just adopted also came with a pet flea. But this tiny moon is incredibly important
because it gives scientists the gravitational key they need to unlock Nysa's secrets. By tracking exactly how fast that moon orbits, astronomers can calculate Nysa's exact mass and internal density.
So how the heck does something like this form? Nature doesn't usually build things with 3 heads, especially not in space, where gravity wants to crush everything into a sphere. There are 2 main theories for our cosmic fidget spinner. Theory 1 is the slow-motion pileup. Billions of years ago, 3 separate, smaller asteroids were floating around in the exact same neighborhood. Because of their relatively weak gravity, they didn't crash at high, shattering speeds. They just bumped into each other. Boop, boop, and they stuck together forever, forming a delicate rubble pile held together by the weakest of gravitational hugs.
Theory 2 is a bit more violent, and frankly, a lot more awesome. It's called the hit-and-run collision. Imagine a massive, planet-sized body in the early solar system getting totally wrecked by a catastrophic impact. Nysa could just be a massive piece of shrapnel from that ancient war, heavily scarred and left with 2 massive gouges, or valleys, carved into its sides as it was ripped away from its parent body. Over millions of years, the debris from that collision coalesced, leaving us with this strange trilobate survivor and its tiny lunar companion.
Nysa isn't just a freak of nature, it's a pristine time capsule. Objects like this preserve the chaotic, incredibly violent history of the early solar system. Every crater and weirdly shaped neck on this rock is a scar from billions of years ago, telling the story of how planets like ours were forged in the fire of cosmic collisions. And it makes you wonder, if a 75-kilometer-wide, 3-headed asteroid with its own moon was hiding right in our own cosmic backyard this whole time, what else is out there waiting to be seen?
We're literally looking at ground-based telescopes rivaling the quality of space probes. The golden age of astronomy isn't coming. It's here. If you want to dive deeper into some of the other terrifyingly weird things hiding in the asteroid belt, click the video right here on the screen. Seriously, you won't believe what's lurking out near Jupiter. Thanks for watching, and as always, keep looking up.